Welcome to Topics in Digital Economics. My name is Paul Belflam. This presentation is about the divide and conquer strategy that can be used to launch platforms. Think of a unique platform, which has no competition, and it's trying to attract buyers and sellers. So it's a marketplace that intermediates between buyers and sellers. To make things extremely simple, we abstract away any type of cost that the platform may have to operate. Also, to simplify, we suppose that there are identical users in these two groups of buyers and sellers, and what matters is how many of them there are. There are NB potential buyers and NS potential sellers who can join the platform. Now, this is important. What is the willingness to pay for these buyers and sellers to join the platform? Well, we suppose that the value they attach to the platform has three components. There is what is called a standalone benefit, RB for buyers, RS for sellers. Think of this as the value that the users can get on the platform, irrespective of whether they can interact with other users. There is some value that the platform gives them, and that doesn't depend on any interaction with buyers or sellers. Now, the second part has to do with interaction. These are the network benefits, the cross-group network effects. So what does it mean? It means, take the buyers here, it means that for a given number of sellers on the platform, little ns, for each of these sellers, a buyer gets this amount beta b, which is the value that a buyer attaches to interact with any seller. So for example, if you think of buyers and sellers interacting with one another and there is a transaction for each buyer interacting with each seller, this beta b can be seen as the surplus that the buyer extracts from interacting with the seller. Okay. Similarly, on the seller side, if there are NB buyers on the platform, the total network benefit is beta S times NB. So beta S is the value that one seller attaches to interact with one buyer. Here you can think of the profit that a buyer makes for a particular transaction. Now, RB plus beta B and S is the total value that a buyer gets on the platform when there are NS sellers, but to join the platform, a buyer has to pay this access fee, which we call AB, and similarly for sellers, a seller has to pay an access fee AS to be on the platform. Okay. Now, buyers and sellers, they've got to compare this value that they will get on the platform with what they would obtain if they stay outside the platform. And their upside options is VB0 for a buyer and VS0 for a seller. Okay, so the game proceeds as follows. The platform sets the fees, AB and AS, and then, based on the observation of these fees, buyers and sellers decide whether they join the platform or not. Now, we've made a very simplifying assumption here that within a group, all agents are identical. So that's going to make this second stage very simple in the sense that, let's see the next slide, that all users will make the same decision. Okay, why? I repeat, because we assume they are identical and they also have the same outside option. So if one buyer finds it interesting to join the platform, all buyers who are just clones of this buyer, all buyers will actually find it profitable to join the platform as well. Okay, so there are four possible equilibrium configurations. Either this is the first case, all buyers and all sellers decide to join, or none of them does, or there are these two other situations where, for example, here all buyers join but no sellers join, and here all sellers join but no buyer joins. Okay, now what are the prices, the fees that will generate these different equilibria? So let's focus on the first one, NB and NS. So this, I repeat, means that all buyers and all sellers join. Okay, well, what is the maximum price, maximum fee that buyers are willing to pay if they in this situation? Well, they are willing to pay up to their standalone benefits, but they've got to cover their outside option. Okay, so this is what they're willing to pay, plus the benefit of being able to interact with all the sellers. Okay, because they accept all the sellers to be there. Similarly, for the sellers, the maximum price they're willing to pay is the difference between their standalone benefit and their outside option, plus the network benefit they enjoy when they interact with all the buyers. Okay. Now, what is the price, the minimum price for which buyers and sellers would not be willing to join? Okay. Well, if the price is larger than what they obtain with the standalone benefit minus their outside option, well, of course here I don't add anything because I want to be consistent with the fact that no buyer and no seller joins. Okay, so they don't expect any network benefit in that case. All right, so this is why this would be an equilibrium. No one participates if the fees are larger than the difference between the standalone benefit and the outside option. Okay, so remember that we are looking for equilibria. So what the agents expect must be what actually happens. Okay, now we have these two other scenario where, take this one here, all buyers join. Okay, so they expect no seller to be there because this is the equilibrium we're trying to construct. So what the most they're willing to pay is the difference between their standalone benefit and their outside option. Okay, but in this equilibrium we suppose that all buyers join, and so what the sellers would be willing to pay is this difference here, plus the benefit of interacting with all the buyers, but still the fee they've got to pay is larger than that, and because of that they don't join. Okay, I'll let you reconstruct the last equilibrium. Okay, so let's put all this on the same picture, right? So I've put AB, the fee for the buyers, on the horizontal axis, and AS, the fee for the seller, on the vertical axis. Okay, now what you see here in the different colors are the combinations of conditions that we had on the previous slide. So if you want to go back to the previous slide later on to check, you can do that. Okay, but for example here, the blue zone is below these two lines, and what are these two lines? Well, that's a price for the seller which is no larger than this, and remember this is the difference between the standalone benefit and the outside option, plus the benefit of interacting with all the buyers. And it must be on the left of this fee here, which is the same thing, but from the buyer's point of view. So if you are on the left of this maximum fee and below this maximum fee here, all buyers and all sellers participate. Okay, but for the same reason, if the fee for the buyer is larger than this, so this is just the difference between the standalone benefit and the outside option, without any any network effect, and same thing for the sellers. Well, in that case, on the right here and above this, you've got an equilibrium where no one is participating. Okay, and finally in the pink zones here, you've got the other two equilibria where one group participates but the other one doesn't. Okay, so that summarizes the decision of buyers and sellers for all potential combinations of fees, AS for sellers and AB for buyers. Okay, now in a sense that describes the demand functions. Okay, so it tells you for any combination of fees, AS and AB, what participation of buyers and sellers you're going to have. Okay, so this is the kind of picture that the platform needs to figure out in order to choose the fees AS and AB. So this is what we do next. Right, so the picture is here again, but as I explained before, in this zone here, so what is below this line and on the left of this line, so the blue zone, and in the green zone, in all this square here, you've got fees AS and AB for which you've got two equilibria. Okay, and then that reminds us what we saw in the very first week of the course. This is just adapted to a situation where you've got two sides, and each side gets network benefits from the participation with the other side. Okay, but that shouldn't surprise us that because of these cross-group network effects, and even if we've got two prices here, we still have this situation where a given combination of prices may give rise to several equilibria. Okay, now the platform is willing to maximize profit. Okay, and profit is going to be AS times NS plus AB times NB. Okay, it's the total membership fees or access fees that will be collected by the platform. Okay, so the platform would like to move up there, right? Would like to get as large as possible an AS and as large as possible an AB to maximize its profit. Okay, of course, it wants to have participants, so it has to be in this zone here. It would like all the buyers and all the sellers to participate. So ideally, the platform would like to be at this point here. But at this point, you also have that no one participating is an equilibrium. Okay, so as a platform operator, do you want to run the risk of setting a fee here that may end up with no one participating? Well, this risk is quite high. So you would prefer to be either here at the red dot or here at the yellow dot. So let's take the yellow dot. I mean, the idea is to make sure that we are in the blue zone, but not in the green one. Okay, so what is the meaning of this point here? Well, this is where divide and conquer takes all its meaning. So in a sense, the platform will decide first to divide. Okay, it wants to evacuate this null equilibrium, so the 0, 0, okay, by guaranteeing the participation of one group. Okay, so it sets AB is equal to RB minus VB0. Okay, so this is here, sorry. Okay, at this price, well, you kind of subsidize the buyers because buyers are willing to participate even if they expect that they will not interact with any seller. Okay, so in a sense, the platform divides the group of buyers by convincing them to participate, even in the worst case scenario where no seller is present on the platform. Okay, now that means that buyers will participate, and this is good because it will convince sellers to participate. Sellers know, seeing this fee AB, they know that all buyers are going to participate. So now they're willing to pay a high price because they anticipate they will gain this extra benefit of interacting with all the buyers. Okay, and so that allows you to raise AS up to this point here and to arrive to the yellow dot. Okay, this is the conquer part. You've divided the group of buyers by convincing them to participate, even if even if no seller is participating. Okay, and once the buyers have joined the platform, you can extract a larger fee from the sellers because you can tell them, look, all the buyers are there, you're going to interact with them, and you're going to enjoy this large network benefits, and I'm going to set a price that reflects the value that I'm creating for you. Okay? Now, of course, you can redo the same reasoning for the red dot here. That corresponds to the other way around, where you would divide the sellers group and conquer the buyers group. Okay? But I repeat, the meaning is to make sure that participation of both groups takes place, but to evacuate the possibility that no one would participate. Okay, so you want the only self-fulfilling prophecy. Remember what we saw in week 1, sorry. The only self-fulfilling prophecy is such that all buyers and sellers participate. Okay, so I repeat, this means that this dot here, which would be ideal for you, you would extract the highest possible prices for both groups, but this is not feasible because if you are here, you run the risk that no one is participating. Okay, so just to make sure, you want to be outside the green zone, and either you choose the red dot or the yellow dot. Okay, but for sure you're going to have to choose a subsidy side, the divide group, the group that you pay to participate in a sense, and the subsidy side will be compensated by a money side, the group that you attract. Second, in a sense, is the group that you will charge a positive fee in order to recoup the kind of investment you've made to attract the first group. Okay. Now, there are two questions. Which group do you choose to divide or as a subsidy side? And second question, is it always profitable to do this divide and conquer strategy? Okay, so let's look at that. First, which groups should be subsidized? Well, let's compare the two options. So the yellow dot was the case where the buyers are subsidized. So this is how much they pay or you pay them. I mean, this could be negative, okay? That is multiplied by the number of buyers. And this is how much you charge the sellers, which is multiplied by the number of sellers. Okay? If you choose the red dot, it would be the opposite. You kind of subsidize the sellers and you charge the buyers. Now, if you compare these two lines, this is very easily done, but you can check the computations by yourself later. You will realize that it's more profitable to subsidize buyers, so to choose this option here, if beta S is larger than beta B. Okay, what does that mean? Remember that beta S and beta B, they measure the strength of the cross-group network effects. Okay, in particular, beta S is how much a seller values the interaction with a buyer. Okay, and beta B is how much a buyer enjoys the interaction with a seller. Okay, so what this condition tells us is that if sellers value more the interaction with buyers than buyers value the interaction with sellers, which is the same as saying that the buyers exert a larger cross-group network effect, or still in other words, that buyers have a larger attraction power, then in that case, it's better to subsidize buyers than it is to subsidize sellers. Okay, the intuition is quite simple. You want to force one group to come and use them as a leverage to attract the other group. Okay, so you're going to choose the group that has the largest leverage, that has the largest attraction power, because that's going to be more efficient. Okay, so what you will recoup by charging the second group is larger if you've started with the group with the largest attraction power. Okay, so subsidize the group that exerts the largest attraction power on the other one. That echoes all the reflection we made about the launching strategies in week 4. Now, remaining question, is it profitable? Can you profitably overcome the chicken and egg problem? Well, you can do so if, let me just come back to the previous slide, if the maximum of these two lines is positive. Okay, positive here means larger than 0, and remember that 0 is what we assume about costs for the platform. Okay, so the question is, can you, with this strategy, knowing that you lose on one side but you recoup on the other side, are you able to cover your costs? In this simple example, the cost is 0. Okay, so it means, if you just play a little bit with the two expressions before, this is a condition for this to be true. Okay, one way to write it is to say that the maximum of beta B and beta S should be larger than this sum here. Okay, now it's easier to understand it by looking at different components of this condition. Okay, so this is more likely to be true if the network effects are stronger, okay, which happens if the values of beta B and beta S are larger, which also happens if NS and NB are larger, because that would decrease the right-hand side. Okay, so if cross-group network effects are larger, you've got a larger chance to be able to launch profitably your platform. Okay, also if you offer larger standalone benefits. Okay, so you see they come here with a minus, so if you increase them, this whole right-hand side decreases and it makes the condition easier to satisfy. Okay, that is also quite intuitive. If you can draw to the platform your users because you offer them standalone utilities, that makes it relatively less important for them to interact with the other group. And we know that the chicken and egg problem comes from this desire for users to interact with one another. Okay, and finally, it's also easier to launch the platform with a divide and conquer strategy if the outside options VB0 and VS0 are lower. Okay, so this is also very intuitive. These outside options, they would be larger if the buyers and or the sellers have very attractive alternatives outside the platform, which could be the case if you face a large competition from other platforms, for example. Okay, so in reverse, if the buyers and sellers don't have very attractive alternative, they have more reasons to come to your platform, and it will be less costly for you to attract them. Okay, so in a nutshell, to summarize, what we've learned here is that because of network effects, we have in two-sided platforms what we already had with one-sided platforms. That is, we can have multiple equilibria, multiple participation levels for a given price structure. Okay, here the price structure is a combination of AB and AS, the access fee for buyers and the access fee for sellers. Okay, so in particular, what we have is that for some combination of fees, the platform can induce both participation by all users, but also participation by none of them. Okay, and a risk-averse platform will try to get rid of this bad equilibrium where no one participates. Okay, so it wants to choose fees that make sure that all users and all buyers participate, and this is the unique equilibrium. There is no other equilibrium. Okay, and so what we've seen is that there are two ways to do that. Both ways follow the same principle, which is to give a very low fee, potentially a negative fee for one group, in such a way that this group will participate even if the other group doesn't participate. Okay, but then, because the participation of one group is kind of guaranteed, you can extract a large fee from the other group that is willing to pay this large fee because they know that the first group is going to participate. Okay, so this is the divide and conquer strategy. And if you offer sufficiently strong network benefits, if you can on top of that offer standalone benefits, and if you face little competition, well, this divide and conquer strategy may be profitable, may allow you to profitably launch the platform. That's it for now. Thank you for your attention.